Hi. Okay, so this will be our part two for our discussion of electric charges and electric fields. I feel that I just rushed into the last part, so I will be giving more of some of the examples and to discuss a little bit of our previous lesson. And don't worry, we just discussed all of the for the preliminary examination. So yeah. Okay, so without further ado, let's have our continuation or our part two of our electric charges and electric fields. Okay, so from last time we have discussed that electric charge has consists of particles of proton, electrons, and other charges. Proton is the positively charged, and negatively charged is known as the electron. So both charges have an equal amount of charge, meaning the net electric charge will be zero. Remember those, guys? You remember this one, guys? Okay, so we have a charge value of 1.6 times 10 raised to negative 19 coulomb for both proton and the electron. Now, the thing about it is the charge value of 1.6 times 10 raised to negative 19 has a positive sign for proton and negative sign for the electron. So basically, they have the same charge value, but they differ in the sign, which is the positive and the negative. Okay, so law of conservation of electric charge. A net electric charge can never be created, but charge can move from one place to another. Okay, so we have discussed that one. So we have here a question. So aside from being a good conductor of electricity, difference of conductor is insulator has missing electrons, and I just want to add in there that insulator also has uh, insulator also lacks of free moving electrons. Okay, so these are another uh, yeah, so this lacks of a free moving electron. Okay, so I hope that this is uh, another knowledge for you guys. So yes, it has an insulator lacks of free moving electron, has missing electron, and lacks of free moving electrons. Okay, so we have already know this one. So let me just discuss it again. Okay, so when the proton or the positively charged particles come in, so another group will come out. So it's not possible for our insulator since it has a lack of free moving electrons. Okay. So electric charge is a property that causes an electrical phenomenon when placed in an electric field. So method of charge, electric charge is friction, contact, polarization, and grounding. Okay. Okay. So yeah, so this is the one that I'm going to show you in a in a simulation. So as you can see, the arrows are going to negative charge and arrows are coming out on the positive charge. So here's a video of this. So we have here the negative charge and the positive charge. So as you can see, uh, when the negative charge is placed in our electric fields, as you can see, forces or the directions of the direction of the particles are going to our uh, negative charge or negative particle. Okay, meaning the direction is the negative one is the attracting part. Oh, the attracting particles in our electric field. Okay, and let's watch it again. So yeah, that is the negative charge, and another one is when a positive particle is placed, you can see that the direction of it is going out. So yeah, there is an arrow moving from the positive going to the negative. So that doesn't mean that the positive charge is repelling. It's just the direction of its attraction is away from him, away from it, and the negative particle is the one that's attracting the direction. Okay. Okay. So let's see. So what will happen, sir, if we have played with it? So what do you say played with it? So meaning when we combine those two. So let's try to combine the negative and the positive particle. So we have here our negative and our positive charge. Okay, so still the same whenever you move, or even if you move our positive and negative particles, they will still have directions that are going to them for the negative and away from them for the negative. So you can see there are a lot of changes in the direction during the time that they are being combined together. Okay, so as you can see here, we have the directions away, but still going back to our combined charge, which as you can see is that the particles are being attracted and at the same time being repelled. Okay, but those two are perfectly fine since they are positive and negative charges. Okay, so let's move on. Okay, so like charges repel, opposite charges attracts. So this is a an easy feat to know the charges of our particles. Okay, so formula for finding the electrical force, so we have here F is equals to KQ1 Q2 all over R squared. So I want to give you some tips and tricks for this. We have the K constant 9 times 10 raised to 9 Newton square meter per coulomb square. This is known as the Coulomb's law. So force exerted by two charges on one another is directly proportional to the product of the charges and inversely proportional to the square of the distance between the two charges. Okay. So there will always be two charge, Q1 and Q2. And still, they are directly proportional kung alam ninyo, kung tandaan ninyo yung ating phi. So this is, the original is F is proportional to Q1, Q2 all over R squared. So since napaltan itong ating proportionality constant will be changed to equals to constant, that's why we have here equal K. Okay? So always remember this. These are the original formula. F is directly proportional to Q1, Q2 all over R squared. So it happens that our proportional constant has been changed to equal K for the reason to be an equation. Okay? So, so yan, that is the trick. So para mas madali ninyo matandaan yung ating formula. Okay. So let's try to have an example. So two electrons apart from each other has a distance of 3 micrometer. Solve for the magnitude and direction of the charges. So we have given of electron which is negative 1.6 times 10 raised to negative 19. And we have R of 3 times 10 raised to negative 6 meters and K of 9 times 10 raised to 9 Newton square meter per Coulomb square. So I'm giving you guys time to solve for this, even though we have solved this uh, before. Okay, so let's please try to solve this one. Okay, so here we have our solution, which is our formula of F is equals to KQ1 Q2 all over R squared, which is we can substitute all of our values, which is K, which is 9 times 10 raised to 9, and we have electrons of Q1 and Q2 of negative 1.6 times 10 raised to negative 19, and another, that's why there is a square. Next, we have to divide 3 times 10 raised to 6 and square it, and we will arrive at the answer of F is equals to force is equals to 2.56 times 10 raised to negative 19 Newton. So as you can see, it's negative 17, meaning sobrang hina na niyan. So hindi niya kayang mag-move ng isang papel. Kahit isang papel, hindi niya kayang paggalaw. So that is the reason kung bakit sobrang liit lang, tiny particles, and maliit lang yung kayang i-push ng ating electrons. Okay, so yan. So since the value is positive, meaning our force is attracted. Our force is repelling to each other, since it is both negative negative multiplied, it will be positive. So kung magiging negative yung sagot natin, the reason of it being negative is because it is attracted to each other. They have different directions. So since it is positive, parehas yung directions nila. Okay? Okay, so let's have another example. So three charges are shown. Solve for the force on B. Okay, so what is it? So we have here three charges connected to each other. So we have here 10 microcoulomb, another 10 microcoulomb, and we have 20 microcoulomb. So apart from each other of 0.1 meter. So we have here charge A, charge B, and charge C. So we will be solving for the charge of B. Okay, so we will be solving for the charge of B. So, sir, why do we have three charges? We need the single for every particle. There will always be one force. Yes, there will always be one force. So now the question is, sir, bakit po bilang yung hinahanap? Di po ba ang force pala natin is kailangan dalawa ng charge? Okay, so dalawang charge talaga. So we have here, we're going to get the charge of A and B, and then B and C. So check natin kung ano ba yung magiging directions nila. Okay, so check natin kung ano magiging directions nila. And doon natin makikita kung paano ba natin kung ano ba yung ating gagawin doon. Okay, so sige. So we have here given of particle A of 10 times 10 raised to 6, negative 6 coulomb, and the distance to B of 0.1 meter. So and we have B of 10 times 10 raised to negative 6 coulomb, and a distance to C of R of 0.1 meters. And lastly, we have the particle C of 20 times 10 raised to negative 6 coulomb. So please try to solve muna, and then we will be moving on after the timer runs out. Okay? So please try to solve this one, guys. Okay, so this is a new example. So wala ito sa ating previous discussion. So let's try to solve for this. Okay, so we have here solution of FAB. Force of AB is equivalent to KQ1 Q2 all over R squared. So substituting the values of this, we have FAB of 9 times 10 raised to 9, 10 microcoulomb and 10 microcoulomb all over 0.1 square. Okay, so using our trusty calculator, so we have here, okay, 3 sets and isa pa for our R squared. So we have here 9 times 10 raised to 9. Okay, so 9 times 10 raised to 9. And we have here 10 times 10 raised to negative 6. So another of 10 times 10 raised to negative 6. And we have here 0.1 na naka-square. So we will be arriving at the answer of 90 coulombs, 90 newtons pala. 90 newtons para for our force of AB. So the formula has been is not violated. The formula is not violated. F is equals to KQ1 Q2 all over R squared, two charges, and we have the value of our force, 90. Okay, so sir, in your example, we have 10 naka-micro, meaning nun 10 times 10 to negative 6. Now, the thing about it is medyo mahaba siya. Hindi siya kakasya sa isang line sa ating uh, sa ating um, sa ating solution. That's why I I put it in a micro. But if in case na sa exam natin gagamitin siya, please put all of it. So, wag kayong magtira. Okay? So, hindi na ninyo kailangan gamitin yung micro symbol. Okay? So, in this the purpose of in this discussion purposes, we have to I just have to shorten it out. Okay? So, but in our computation, you can see in our calculator, we use 10 times 10 raised to negative 6. Okay? Okay, so that is it for our force AB. And now we have force. Okay, wait. We have the direction. Okay. So since it is positive, we have the direction going to C. So we have three charges lang. Okay, so we have three charges lang. So we are going to the direction of C. Okay. So next is we have our FBC. So since we have BNC, then we didn't violate our formula, which is KQ1 Q2, two charges pa din, which is BNC. And we have yes, we have substituted all of our values, which is K, Q1 and Q2. So let's try to solve it in our calculator. Okay, so we have here 9 times 10 raised to 9, and we have 10 times 10 raised to negative 6, but we have here 20. So we're just going to uh, 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 we have to edit a little bit, which is instead of 10 we will be inputting 20. Still the distance is the same, 0.1 squared. We will be arriving at the answer of 180. Okay, 180 to the direction of A. So sir, bakit po? For the reason na we have three charges lang, wala namang pupuntahan si C sa kabila, sa kanan. So we will be going to the left. Okay, to the left. We will be going to the left. Okay? Papunta naman siya kay A. So, since we have here two different charges, we can easily get the force value of B, which is 180 minus 90 and equivalent to 90 newtons. Okay? So, I hope guys na naging clear ito sa inyo. And ito yung isang part dito na we have to take action. So we have just three charges. So meaning, uh, as you can see, it's also positive charge. So the positive value, the charges will be away. So since away, positive yan. So that's why papunta si C KA kasi away nga tayo and si A naman papunta kay C. Okay, away tayo. Tandaan niyo our charges, the direction of the charges. Okay, so para matandaan natin, the direction of the charges. Yan, ito. So we know that when we place it in an electrical field, kahit tatlo pa yung mangyari dyan, so um, tatlo kahit maging tatlo yan, ano pa din yan, magkakaroon pa rin tayo ng electric, the direction of our charges will not differ. So away yung ang positive natin ay away yung direction and negative natin is going to going to itself. Okay? So I hope na naging clear yung ating example na ito, guys. Yan. Okay, so hindi naman siya mahirap intindihin. Yung direction talaga that always matters. Okay? Okay, so let's have electric fields. An electric field is a measurable effect generated by any charge object. So charges in electric field, we have point charge Q, capital Q, and test charge, small letter q. So in order to know the value of the electric charge, we have here E is equals to F all over test charge. So we have a formula, guys. Ito nga pala, gusto din niya bigyan ng emphasis to. So we have here the formula of our F of our force, electrical force of F is equals to KQ, Q1, Q2 all over R squared. So in this case naman dito, we have here the test charge and we have here the test charge and we have our test charge and our point charge. Okay. So by substituting, so as you can see, guys, eto. So yung F natin dito, nung napunta siya dito sa substitution part, ang ipinalit natin sa kanyang value is etong ating formula ng F. Formula of F, okay? Formula of F is KQ Q all over R squared. So ang magiging writings natin dyan is KQ Q all over R squared parenthesis of all over Q. Okay. So remember this part, guys, ha. Remember this part. KQ Q all over R squared all over Q. Test charge. Okay, so nag-iba siguro yung perspective niyo dito. Now, again, rewrite natin ulit siya. K Q all over R squared and Q. Okay, so sir, bakit po magkasama na po ang ating R squared and Q sa denominator side ng ating equation? So, di ba ang denominator at denominator pa ng isa kapag pag nasa ibabaw ng isang denominator ang isa pang fraction, yung denominator natin is bababa lang siya, di ba? Bababa lang natin siya. Parang yun yung simplest explanation. So, yung ating denominator sa dun sa ating taas, dun sa numerator side, K, Q all over R squared test charge. So, etong denominator na R squared natin, bababa lang siya kasama ni Q test charge. So, since we have here KQQ all over R squared, our test charge here will be cancelled. So, matitira na lang dito is si KQ all over R squared. Okay, so KQ all over R squared ang matitira. So, let's see kung yun nga test charge Q will be cancelled and we will be having a formula of A is equals to KQ all over R squared. So, same lang yung lalabas natin dyan. Okay? So, same and lang, I just want you guys to see the derivations on how our formula arrived to its working equation. Okay, so we have here our working equation. We have our working formula of E is equals to KQ all over R squared. Okay, so unit natin is Newton per coulomb. So, sir, bakit po naging Newton per coulomb lang? As you can see, we have a missing charge. That's why yung ating electrical field, hindi siya Newton. That is Newton per coulomb. That's why, as you can see, we have canceled the other Q, the test charge. And if we have another charge, that will be force na. Hindi na siya electric field. Okay. So positive electric field, the direction of our charge is the direction of our point is that the positive charge is moving towards to a certain point. Also, that certain point is parang nandun sa ating electrical field kanina, dun sa video. So we have placed a charge in there and the direction of a positive electrical field is moving towards to a certain point. Okay? And the negative electrical field we have here, the charge is moving towards to our negative charge. So, siguro naman kanina napansin niyo guys, yung ating electrical charge na place natin dun sa ating electrical field, which is um, the direction of all the particles is moving towards to our negative charge. So we have E is equals to KQ R squared towards the point, and D is equals to KQ R squared pa rin. Approaching the charge naman tayo for the positive and the negative charge. Okay, so always remember the video that I showed you a while ago, that those particles has a direction na para lang sa kanila. So, hindi pwedeng maging positive ay papunta yung charge papunta sa positive. Always na nag-give away ng charge ang ating positive charge. And ang receiver naman is the negative particle. Okay, so we have here a mixture of positive and negative. Uh, yan. Always papalayo ang ating positive charge and papunta naman ang ating negative charge. Okay, so always remember the positive charge always give away positive, and the receiver will always be negative. Okay, so yan. So we have here a negative 200 microcoulomb and positive 300 microcoulomb. So yan. Okay. Yan. So please try to solve for our magnitude of the direction ng ating electrical field. Okay? So yan. So I'll be giving you guys ample time to solve for this, and kahit na-solve na naman natin to last time, so please try to solve pa rin. Okay, so sige. Okay, so let's try to solve this one. So let's solve this one. So we have here our positive particle approaching the point. We have E is equals to KQ all over R squared. We have a positive 300 times 10 raised to 6 multiplied to our K, which is 9 times 10 raised to 9. And divided by 0.3 square, we have value of 330 times 10 raised to 6 Newton per Coulomb. So we have here another particle of negative charge. That the point is moving towards our negative particles. We have here E is equals to negative E KQ all over R squared, we have negative 200. And we will have our electrical field of negative 1.065 times 10 raised to 6 Newton per Coulomb. So we have here our E net, or our net electrical field of 30 times 10 raised to 6 plus negative 1.065 times 10 raised to 6. We have here the value of 28.94 times 10 raised to 6 Newton per Coulomb away from the charge, meaning going to the right. So since our drawings is that our positive particles is in the middle and here is our point, so meaning our charge or our point will be away to our charge. Okay, so I hope guys that this is clear to you before we arrive or before we proceed to our next example. So I hope that this is clear. So we have here another example. So what is the force of an electron if the value of electric field is 5 times 10 raised to 5 Newton per Coulomb. So force naman yung tinatanong natin. We have here an electron. Okay, so force naman yung tinatanong. So please guys, so please try to solve this one. And let's see kung paano natin gagawin to. Okay? So, please proceed guys. Okay, so here it is. So let's try to solve this one. So we have an electron and we have our electrical field of 5 times 10 raised to 5 Newton per coulomb. So I guess medyo mahirap isipin kung paano ba ito. But then again, we have to consider the units. So it's just Newton and Newton per coulomb and coulomb. So how are we going to do that? So since it's Newton per coulomb over coulomb multiplied to another coulomb, so cancel, we will be having Newton. So force na ang ating Newton. So F is equals to Newton. So tapos na agad. Force is equals to Newton. So pero hindi yan ganun kasimple. So 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 for this, we have our solution of E is equals to F over Q. F all over Q, but we are looking for our force. So we have to cross multiply E and Q to arrive at the formula of force is equivalent to our electrical field multiplied to our charge. So since we have that, let's try to solve for this one. So substitute natin. Our electrical field has a value of 5 times 10 raised to 5 and we have our charge of electron which is negative 1.6 times 10 raised to negative 19 C. So we will be arriving at the value of 8.14 times 10 raised to negative 14 Newton. So for this guys, as you can see, we will be having a negative value. So let's try to solve for this one. We have negative 1.6 times 10 raised to negative 19. And another one is 5 times 10 raised to the fifth. So we will be having here negative 8. So ito pala yung 14 natin, typographical error. So, but it doesn't matter, maliit lang naman yung 0.14. So we have here our value of negative 8 times 10 raised to negative 14. Sir, what happened to our negative sign? So for the negative sign, pag force yan, wala tayong negative force. Meaning, direction lamang yan. Okay? So our negative sign here is just an indication of where our force is going. It can either be going to the right or going to the left. So it's just an indication of our direction. It doesn't matter. Hindi siya katulad ng ating positive charge which is may positive tayo dyan para malaman natin that it is belongs to a positive particle. So yung ating negative naman sa electron, it is just to show everyone na negative yung nature ng ating charge. So when it comes to force, sign, positive or negative really don't matter sa value. Nagmamatter lang yung ating positive and negative sign sa charge sa direction. Okay, so when it comes to force, it is okay kung wala na yung negative and positive sign natin sa ating final answer. So it's just only indicates the direction of our force. Okay, so I hope this clears everything, guys. And I hope na naging maayos yung ating naging discussion sa araw na ito. So if you have any questions pa, feel free to ask. So let's move on to the next. So electric flux. Meron lang akong gustong i-clarify dito sa ating formula. Yes, this one, the derivation of our formula. We have here our formula of electric flux, which is phi E is equivalent to Q all over permittivity of free space. But how did we arrive at the formula of phi E or phi E is equivalent to our charge all over permittivity? So here we have our original formula of electric field times the area. So electric flux is equivalent to our electric field times the area. Okay, so we have here our formula of our electric field of KQ all over R squared. So we have here our formula of E is equals to KQ all over R squared and our area of 4 pi R squared. 4 pi r squared. So, substituting these values substituting these two, E and A, the formula of E and A sa ating formula. So, this is what it looks like. K, Q, all over r squared multiplied to 4 pi r squared. So since ito ay ating numerator, kasi meron pa tayo ditong denominator na 1, we can cancel out our r squared. Okay, so we can cancel out our r squared. So what will remain is kq 4 pi. Okay, so kq 4 pi. But then again, kung ito na lang yung matitira natin, so paano tayo nag-arrive dito, sir, sa k all over permittivity of free space. Okay, so is our here is our another value of our k. Okay, another value of our k, which is k is equivalent to 1/4 pi permittivity. Okay, so if this is k, which is 1/4 pi over permittivity, we have here our q 4 pi, and thus the value of our k, which is 1 all over 4 pi permittivity. So we can cancel out our 4 pi, and yung 1 naman natin, hindi naman mahalaga yan. Any number multiplied to 1 will always be 1. Okay, so we will have here our since na-cancel na natin yung ating 4 pi, what will remain is our q and our permittivity of free space. That's why our formula of our phi e is equivalent to q all over permittivity. Okay, so that's how it is. That's how our formula of our electric flux has been formed. So, but don't get me wrong, if we have a given of electric field and area, we have to use our original formula of E times A, electric field times A. And we have here our another formula of charge of Q all over permittivity of free space. Okay, so for our what do you call this? Units. Okay, so we have here our electric field of for our units. Let's go for our units. For the units, we have here E is equals to Newton per Coulomb, and we have here our area of M squared. So that's why when we combine these two, we will be having a unit of Newton square meter per Coulomb. So that's it. So yun lang, guys. So if you have any questions, so feel free to ask your teacher. So thank you and God bless. See you soon, guys. And this concludes our topic for today, our discussion for today. So thank you, guys. Peace out and be legendary. Bye.